obviously essential for tree growth. Water is taken up by the roots. The process isn't terribly complex. I'm not going to say much about it. Also, the water moving in is what's carrying our nutrients in. So we got to have water for tree health, for growth with the nutrients. And it also affects the penetrability by roots. And this one isn't really out there a lot, but some work at Virginia Tech I thought was pointing very much to this. So when we have a wet soil in the spring, we can actually get roots growing into soil that the roots aren't going to grow into in the summer when it's drier. So that soil moisture will affect the penetrability. There are ways of measuring penetrability, these penetrometers. There is a little bit of data out there. We don't really want to get this penetrometry confused with density because, again, this is water dependent. Basically, the more water we have, the less penetrability we have. But if you're using those devices over 300 psi, and you're getting to where roots aren't going to penetrate very well. Okay, so with water, I'm concerned about two specific cases that you probably are concerned with as well. One is the new transplants, and this is a new transplant. It was a big one. I think it was a $20,000 job. They've got a lot invested in that tree, key position in the landscape. We're really concerned about that tree. This one had a teardown. It's a teardown situation, okay? They had a building there, they tore it down, they built a new one, and they want to keep that tree. And these are two real important cases, I think, where we might want to get the water right. And we as an industry have a bit of a tough time getting the water right. We see the left case, that actually is a photo from Mesa, Arizona. Okay, we're in the middle of a desert and the darn tree is dying because of too much water. But the more common one that we think of is the drought situation. And again, how do we get this right? How do you guys get that right? So one is just looking at the soil, and if we see this sort of thing, the dry surface, the cracking, the dusty, we know we've got some problems there. The problem was I was seeing that yesterday. So it's an indication, but it's not the full story quite often. We can go out, we can core soil. We can take our bucket auger, our Dutch auger, or just a soil probe. We can take samples out. We can look at it. We can feel it. And that's a good way of doing it. There's nothing wrong with that. But it takes some knowledge to do that. So you can't necessarily ask any client to do it. I think probably anyone in this room could do a good job of that. But your client probably not going to do a very good job of this. We could also take subsamples from that. We could take them home, put them in the toaster oven, cook them up, weigh them before, weigh them after. We can tell exactly how much water. We can get very precise water levels. So we've got a bunch of different devices out there that you can use. And that's what I'm going to talk about. I'm going to run through these different devices, and maybe you can pick one out that you want to use. Okay? This one, a resistive probe. What it's basically doing is it's measuring the electrical resistance from this tip over to here. Okay? And there's a little plastic washer in between. So it's basically sending an electric current through the soil right there. What could go wrong with that, right? A lot of things could go wrong with that. And it's going to give us a number between 1 and 10. And it's not going to tell you what that means. It's just going to give you a number there, okay? And again, the one side, it's probably pretty dry, and the 10 side is pretty wet, but I don't know what those numbers mean. So the other thing, since we're just looking at electrical resistance, salt's going to have a huge impact there. So if they've fertilized or anything like that, it's going to give you a distorted. So there are limitations with this, but it's a tool, and it actually gives you a number. And if you're using it on the same property, the salt is going to be the same, the texture is going to be the same, and it'll give you some good information. So I don't want to badmouth it too much. I don't think it's perfect, but it gives you a number. You can remember that number for next time. You can see, it's in the middle. It's like a 5. That's probably okay, I guess, but I don't know what that number means. But it's probably okay because it's a 5. It's in the middle of the dial. It's a good thing it doesn't go up to 15. because then we wouldn't know what to think. Another one is tensiometers. Okay, this is really old technology. We got a hollow tube, we got a ceramic tip, and we have a vacuum gauge. So as the soil dries out, the water moves out of the ceramic tip into the soil to come to equilibrium, and it creates a vacuum within that gauge. And it gives you that number on the gauge, easy to read. That's pretty cool. What are the limitations? Anyone know? Probably listed right up there. Well, okay, here, can we do it at this time of year? Well, you actually can, but is it practical this time of year? Well, you could do it if you really wanted to. And the way to do that is you can actually fill them with antifreeze, with like RV antifreeze, and it'll work the same and it won't freeze. But most people don't do that. They put water. And this isn't the real problem. The real problem is in here, where if that water freezes, it'll break the gauge. So you got cold temperature limitations with these. You also have limitations. So if they're not paying attention to this, if they're only checking it, say, once a week, it can dry out. And when it dries out, it goes to 0. And when the soil's saturated, it goes to 0. Do you see any problems there? It gives you the same reading for either extreme, okay? And that's a real problem, because if they're not thinking and they read that and it's at 0, they're going to water it, and it could be saturated. So, but if you avoid that and a competent person is using it, this is a good device. It's relatively inexpensive. You can buy 1, 2, 3, 4, whatever you want, and it's reasonably priced, $85 bucks a pop, which is really, I think, actually high for that, but that's what they're getting for them now. Works best in wetter soils, works best in clay soil, so you're good here from that perspective. But again, if it gets too dry, it's going to suck all the water out of it. It's going to dry out and give you a 0 reading. So you have to come back in, fill it up, you have to pump the air out, but then it'll start working again as long as it hasn't frozen. So not bad. The electrical block. So that sort of thinking this is sort of the next generation of that. So they've gone from purely mechanical to electrical. So it's going to, inside of that bulb is wrapped fiberglass and a little bit of lime, and that will neutralize the salt, so it sort of takes that salt out of the electrical resistance. And it'll basically measure that electrical resistance between the layers of metal. And this one is also dependent on the water tension. So the water will be sucked out of it when it's dry, the water will go back in when it's moist. And you can hook it up to a little device like this and get an instant reading. Or better yet, and I use this on bigger projects, you can go to a box that'll hold 7 or 8 of those, and it will record the data. So you can look at it over the course of a day, a week, a year, whatever you want. You can see where the problems were. And you can also hook these up to controllers, and that's sort of a neat thing too. We can talk about later. So that's electrical resistive blocks. This is probably a step up from that. Again, it's similar sort of thing. This is the water sensor. This is a capacitive meter, meaning that it's measuring something different in the soil. It's measuring how the capacitance, the electrical storage capability of the soil is measured. And we're not too worried about that, but it gives you fairly quickly, fairly accurately, it will tell you what the volumetric water is in the soil. So the first couple, well, the tensiometer and the block were soil tension. Okay, that's the suction that the roots have to overcome in order to take up water. This one gives you volume, how many inches of water per foot of soil, if you want to look at it that way. So it's a little bit different measurement. The result numbers are a little bit different. So you have to go to the right table to interpret these. Moderately priced, 90 bucks a probe. The recording devices are a little bit more expensive, starting around 300 bucks. And again, you can have multiples of these. So if you have a big project, you can run them all to one box and monitor the whole site. The same sort of thing, the capacitive sensors. This one is newer technology. It's called time domain reflectometry. It's again measuring the electrical capacitance of the soil. And again, I hope you don't ask me any questions about that. It's called a TDR meter. And again, it gives you very rapidly, very accurately the volumetric water capacity, or how much water is in it by a measure of volume. Cost pretty expensive here. $750 for this one. This meter you can move around and poke into the soil. They also have permanently installed ones. But if you need accuracy, fast reading, that's a good one. Similar to that first one that was a lot cheaper. This one's going to be a lot more accurate. Okay, so where do we use them? Again, tree, at least $10,000 to move this tree. It's down south. This is sort of the configuration that we like to see. 2 or 3, in this case we're using tensiometers, 2 in the ball at different depths. You can get different depths, so usually we go 6 and 18 or 24 inches, so you can see how the water is moving through that soil. Is it moving up from the bottom? Is it draining out? It can show you that. And then I like to have 2 in the backfill so that we can make sure that backfill has adequate moisture so that we know the roots can grow into it. So again, if you're spending $10,000, $20,000, $30,000 on a tree, this now becomes very cheap insurance. And again, the trick is reading them routinely and acting when they need action. So you can avoid overwatering, avoid underwatering, and save that job, hopefully. And let me come back to mulch again. You know, if we're concerned about soil moisture, we got to be talking mulch. Okay, this is our best tool for conserving soil moisture. So if we're worried about it, let's get some mulch on there. It's really going to help that water loss situation.